Electrophilic substitution reaction in benzene, specifically nitration. This is today's lesson. In this lesson, we are going to learn reaction between benzene and nitric acid in presence of concentrated sulfuric acid, and then mechanism of the reaction. So, let's begin. The first point is reaction between benzene and nitric acid in presence of concentrated sulfuric acid. Let's write the reaction. This is benzene. Each corner of the hexagon, that means 6 carbon atoms, carry 1 hydrogen atom each. When this benzene is treated with nitric acid in presence of concentrated sulfuric acid, then 1 hydrogen atom is replaced by nitronium ion. That is, 1 hydrogen atom breaks away from benzene and nitronium ion bonds to that carbon atom to form this compound, that is nitrobenzene, and water is formed as byproduct. That is, 1 hydrogen atom is replaced by nitronium ion to form nitrobenzene. This is the reaction between benzene and nitric acid in presence of concentrated sulfuric acid to form nitrobenzene. Nitrobenzene is a kind of liquid, pale yellow to dark brown color liquid. This is slightly soluble in water. Now let's see mechanism of the reaction. Now the point is mechanism of nitration. Let's write the reaction first. Benzene is treated with nitric acid in presence of concentrated sulfuric acid. Then nitrobenzene is formed and water is formed as byproduct. This is the reaction of benzene with nitric acid. Now let's see mechanism of the reaction step by step. Step 1. Concentrated sulfuric acid reacts with nitric acid in this way. Sulfuric acid structural formula of sulfuric acid, in which oxidation number of sulfur is +6, and this is nitric acid, HNO3. Here oxidation number of nitrogen is +5. According to oxidation number, it is said that sulfuric acid is a stronger acid than nitric acid. So here sulfuric acid donates proton to nitric acid because sulfuric acid is a stronger acid than nitric acid. So here sulfuric acid acts as acid and nitric acid acts as base according to Arrhenius ionic concept. Sulfuric acid donates proton, nitric acid donates hydroxide ion here, and this bond undergoes heterolytic fission. As a result, here nitronium ion is formed. This oxygen nitrogen bond undergoes heterolytic fission because hydrogen ion produced from nitric acid bonds to oxygen. That is why positive charge is developed on oxygen atom. For this reason, This bond undergoes heterolytic fission, and as a result, nitronium ion is formed. And after releasing this proton from sulfuric acid, bisulfate ion is formed, and this proton and this hydroxide ion form water. So from the first step, nitric acid produces nitronium ion reacting with sulfuric acid. Step 2, this nitronium ion interacts with benzene. Benzene is electronically rich compound. That is why this nitronium ion attacks any carbon atom of the benzene ring, and as a result, this is formed hydrogen, here nitronium ion bonded to this carbon. As nitronium ion is positively charged, inside benzene positivity is created, which is called sigma complex. Now, because of this positivity, these covalently bonded electrons move towards this positive charge. These bonded electrons move here, not these bonded electrons, because hydrogen's electronegativity is 2.1, nitrogen's electronegativity is 3.1. That is why covalently bonded electrons of carbon and hydrogen move towards this positive charge, and as a result we get this compound. Positive charge is diminished because of these covalently bonded electrons, and proton is separated. Step 3, this proton bonds to bisulfate ion again, which is negatively charged, to form sulfuric acid that can be reused. This sulfuric acid can be used again to form nitrobenzene from benzene, and here water is produced as byproduct. This is the mechanism of nitration, in which benzene reacts with nitric acid in presence of concentrated sulfuric acid to form nitrobenzene. Now let's see importance of nitrobenzene. Now the point is importance of nitrobenzene. Nitrobenzene is pale yellow to dark brown liquid which is slightly soluble in water. This nitrobenzene is basically used to produce aniline. It is used to produce lubricating oils that is used in motors and machineries. Number 3, nitrobenzene is used to produce dyes, drugs, pesticides and synthetic rubber. This is all about electrophilic substitution reaction in benzene, specifically nitration and importance of nitrobenzene. Number today, thank you very much.